Here is a short overview of our solution for automation process of creation of low-level design documents. Zero-touch provisioning process and automation of testing process. Test lab architecture. Our test lab for setting up environment for configuration and test automation consists of GNS3 server and GNS3 worker servers, which host virtual routers. Aim is to automatically provision virtual router upon powering up. Inventory server, which contains all details related to the new added devices in network. Zero-touch provisioning, ZTP server, which prepares configuration and configure new devices. DHCP server, PRTG server, which is used to perform tests on new added devices. Call flow. Upon powering up, router starts boot up sequence and sends DHCP request to DHCP server. DHCP responds with several parameters like IP address, default gateway, and DHCP option 67, in which router can find address from where it can collect the boot script. After receiving DHCP response, based on option 67, router is sending download request to ZTP server, which listens for such request. In response to download request, ZTP server returns initial Python script, which router starts to execute. As part of initial script, router has to collect local IP address and its serial number, and has to set relevant SSH parameters, after which it sends config request back to ZTP server with included serial number and IP address parameters. ZTP server captures these parameters from config request and sends response back to the router that it can continue with the booting process. After this, ZTP server in the background sends a request to inventory server including the router's serial number. Based on the router serial number, inventory server is sending response with the relevant specific device data for generating a configuration file. After preparing specific configuration file, ZTP server is making SSH connection back to the router, applies the configuration file, and performs some basic connectivity tests. Last step is that ZTP server is adding new device to PRTG server via API interface, and PRTG starts pulling statistics from new device and monitoring process. Demo. Now we will demonstrate how this call flow is actually working. On this screen, it can be seen that initially PRTG doesn't have any added device in testing pool. On the left side is screen presenting ZTP server listening on configuration request, and on the right side we are following router booting sequence. Router device now starts booting process and sends DHCP request. This is the response from the DHCP server containing information where to get the initial Python script. Now router device sends a request to ZTP server for Python script. Now we can see that the request has been received and that the script is sent back in response to router device. We're seeing now that the router executes Python script, executes given commands, it finds serial number, setting SSH, and sends back configuration request to ZTP server. ZTP server accepts this request and immediately is making request to inventory server for device details based on serial number. After receiving response from inventory server, ZTP server generates configuration file and pushes down configuration to the router. On the right side, we can see log entries, where the router is receiving and executing configuration file. And on the left screen, we can see some outputs that were collected from the router by the ZTP server. And as the last step, we can see that ZTP server added new router device to to PRTG, and that PRTG started monitoring process of the new device. Automation of low-level design documents creation. Aim is to use the Robotic Process Automation, or RPA, to automate creation of low-level design documents for each location. RPA logs into the inventory portal. The inventory is used for storing all data about location, equipment, IPs, and how the equipment is connected in the network. RPA is opening the sites section where we can find the list of each location with the details like name, region, and type. RPA is an opening more detailed view about location. Here we can scan for data like location name, date of creation, address, GPS coordinates, map view. RPA is scanning for equipment model, serial number, and rack layout. Now RPA is generating the low-level document, or LLD, from existing template with all the relevant data collected by the RPA from inventory server. Same procedure is repeated for different type of location. Scanning data such as name, time of creation, the address, GPS coordinates, and map view. The site type, serial numbers, the rack layout, and generating the low-level design document. All low-level documents are automatically exported and saved in PDF format.